So for Unit 5, Lesson 3, we're looking at graphs of polynomial functions again, just part 2, okay? So it's the exact same learning goal. We're going to be able to identify key characteristics. We're just going to get lots and lots more practice with this, okay? So there is a handout posted on Google Classroom. It would be easiest if you have a printer to print it because you'll see that there's quite a bit to write out. However, if you don't have a printer, just copy out the chart, okay, and then roughly sketch what each of these look like, okay? Don't forget to write their equations here, but roughly sketch what they look like. You don't have to be super accurate and actually graph them if you don't want to on like little you're graphing sticky notes or on graphs, okay? Just sketch what they look like, and this is, the graphs are a lot darker on your actual handout. Okay, so you need this handout to be able to work through this lesson with me. Okay, so what I'm doing is going through a bunch of examples. If you have printed this handout, there are some slides that you need to write extra information. It's not just this handout for this lesson. So either have your notebook beside you or write on the back of this handout if you have printed it. Okay, so one key learning thing here that you need to know, I kind of explained it in the previous lesson, but the graph of polynomial functions of degree 0 horizontal lines. So horizontal lines are like this. Okay, the shapes of other graphs depend on the degree of the function. So the 5 typical shapes are shown for various degrees. So if you have a degree 1, okay, if you have degree 2, a degree 3, degree 4, a degree 5, these are their general shapes, and I'll explain why. So a degree 1 has no turning points. It is just a straight line. Degree 2, though, has 2 different lines with 1 turning point. Okay. Degree 3 has like 1 line, a turning point, another line, a turning point, and then another part of the line. 1, 2, 3. So you see degree 3, it matches the 3 lines, and it has a turning point here and a turning point here. Okay, so 2 turning points. For degree 4, you see 1 turning point, 2 turning point, 3 turning point, 4. So 1, 2, 3, 4. Okay, and then how many turning points? 1, 2, 3, so 3 turning points. Okay, and then for 5, you see 1, 2, 3, 4, 5. Okay, and it would have 1, 2, 3, 4 turning points maximum. So that is key when you are looking at the degree of the function to help you understand what the shape of the graph is going to look like. Okay, so if you see an x to the 5, it can't be a straight line. Okay, that's kind of what that's getting at here. Okay, so looking at our chart, okay, we are going to complete these questions together. Okay, there are a couple, I'm going to go through 4 of them, and then I'm going to kind of go off of the graph again, and then go back to the remaining ones, okay? So again, keep in mind that this lesson is a little bit longer, but it is longer for good reasons so that you understand, okay? So remember, the coefficient of the leading coefficient is the coefficient of the term with the highest degree in the polynomial. You should know that, okay? So for our first example on that worksheet, we're going to fill this out together, okay? So because you have a degree 2, you should know that it looks like a parabola, okay? It's a quadratic. So your degree, just looking at your equation, is 2. Is it even or odd? Well, you know that 2 is even. The leading coefficient is positive, so look out front there. It is positive 1, okay? So looking at your graph of your end behaviors, as x approaches negative infinity, y is approaching positive infinity, okay? And as y is approaching positive infinity, x as x is approaching positive infinity, y is approaching positive infinity as well. You don't have to always put that positive, it's up to you. Okay, number of turning points is 1. You can see it right here. It's going from like coming down here, and your y's are getting smaller and smaller and smaller. It turns, and now all your y's are getting bigger and bigger and bigger. So that's what's considered the turning point. So you have 1 turning point, and your zeros are where your graph crosses your x-axis. So you have 2. Okay, so oops, this one filled it in for me. The rest of them don't. Okay, so as you're doing that, it's going to be the same for each of our questions that were asked. Okay, so our next graph here is a graph of degree 4. Okay, it is an even degree. So even degree, remember that we have the same end behaviors, so both are pointing down, and it's because our leading coefficient is -1, and so that leading coefficient tells us that our end behavior is going to be pointing down. Okay, so as x approaches negative infinity, y is approaching negative infinity. As x approaches positive infinity, y is approaching negative infinity. So both of those are negative infinity there. Number of turning points, 1, 2, 3. And your number of zeros, so that's where your graph is crossing your x-axis, is 1, 2, 3, 4. There. Okay, so again, it's going to get kind of repetitive and redundant, but you just have to understand how to fill this kind of thing out. Okay, so again, equation and your graph and your degree. So looking at your equation, it is degree 4, or you should be able to see it's going to be an even degree from your graph because both the end behaviors are the same. Okay, leading coefficient is a +3. It is positive. Whoops, positive because both your end behaviors are pointing up as well. As x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches positive infinity. Okay, number of turning points, 1, 2, 3. And your number of zeros, we don't ever cross our x-axis here, so you have 0, 0 zeros, if you want to state it that way. Okay, next example. So for this handout is a degree 6. Ooh, a little bit bigger than we've seen. Okay, so degree 6, that is an even degree. Our leading coefficient is +2, so we know that it's going to point up. Our end behaviors again are the same as that last graph because they're both pointing up. So x approaching negative infinity, y is approaching positive. X approaches positive, y is approaching positive as well. Number of turning points, 1, 2, 3, 4, 5. And then the number of zeros is only 1, 2 there. Okay. So that is kind of like the same for each example there. If you see at the bottom of your graph, I'm just going to go back first, or of your handout, you will see those 4 examples we just went through. So we just did 1, 2, 3, 4. Okay. Then at the bottom here, it says for even degrees, your number of turning points. So if you look through, the number of zeros is the maximum your degree. So you can't ever have more zeros than what your degree is. So if you have 4, the maximum that you can have is 4, but you can have anything under it. Okay. But the number of turning points is 1 less than your degree. So you can fill that in and I'll explain. So I'll go back through our examples here. So the example here, you have a degree 2. Well, 2 minus 1, the number of turning points is 1. Maximum number of zeros can be 2, and we have 2 here. Okay. This example here, Degree 4, number of turning points is 1 minus that, 3. Maximum number of zeros can be 4. Well, we have 4 here. Okay. Next example, we have a degree 4. We have 1 minus that for our number of turning points, which is 3. Number of zeros is 0. That is fine. It can be anything less than 4. Our degree here is 6. How many turning points? 1 less than that, so 5. Number of zeros can be anything less than 6, and we have 2 in this case. Okay, so that is kind of a summary of how you can figure out the number of turning points is 1 less than the degree. Okay, going off of that chart for a second, we're going to describe end behaviors of each function, the possible number of turning points, and the possible number of zeros. Use these characteristics to sketch possible graphs of the function. Okay, so because we know that we have an even degree, we know that the end behaviors are going to be the same. Okay, so we know that as x approaches negative infinity, y is going to approach positive infinity. As x approaches positive infinity, y is going to approach positive infinity as well. So just by thinking of that graph. Okay, so we know that our end behaviors, we know that that's what our end behaviors are going to be because we know we have a degree 4, we have 3 turning points, and we know because we have a positive leading coefficient, it's going to point up. Okay, there's our 1, 2, 3 turning points. Turning points are 4 minus 1, so maximum 3 turning points. So you see the 3 there. Okay, 1, 2, 3. As x approaches negative infinity, then y is going to approach positive. And then as x approaches positive, y is going to approach positive as well. Okay. Then using the what I just said, the number possible of turning points would be 3 because it's 4 minus 1. The possible number of zeros, remember, possible number of zeros is maximum of zeros is maximum what your degree is. So maximum 4 or max 4 or anything less. Okay, so it can't be 5, 6, 7, 8, 9, but it could be 4, 3, 2, 1, or 0. Okay, and then using these characteristics, we're going to sketch possible graphs of our function. So you know that using your end behaviors of the function, we can sketch possible graphs of 4th degree. We're going to start in our second quadrant and end in our first quadrant because you know that it's going to have to point up. Okay, so the graph must have an odd number of turning points, so 3 turning points, as we already said. And then since the function is 4th degree, it may have anyone from 0 to 4 x-intercepts, which I just said on the previous slide as well. Okay, so some examples would be we could have 1 turning point, okay, and we could have 0 x-intercepts. We could have 2 turning points, so this is kind of a silly turning point. 1, 2 turning points, and we could have 1 x-intercept. We could have 3 turning points, and we could have 2 x-intercepts, or we could have 3 turning points, so 1, 2, 3, and we could have 1, 2, 3, 4 x-intercepts. Okay, so most of the time, you're probably looking at this and being like, oh, Miss Mitchell, that's a quadratic. Okay, and it's probably because it can be factored, and then that is why it's going to look like that. But typically, if I was looking at a graph, you're going to see that x to the exponent 4, anything with an exponent 4, is going to have 3 turning points. It could have 1 or 2, but generally it's going to have those 3 turning points. Okay, again, we were just doing possible graphs of the function. These are not the exact graphs of the function. We are doing possible graphs of what this function could look like. Okay, using 3 turning points, 2 turning points, 1 turning point, or 0, 1, 2, 3, 4 x-intercepts. Okay, so The question here is, why must all polynomial functions of an even degree, so 2, 4, 6, etc., have an absolute max or an absolute min? Absolute max or absolute min is just like the greatest or the least value. Greatest here, max would be, or minimum would be least. Okay, value that a function is able to get for its domain, okay, or its range. So why you have that is because for an even degree, remember we have our same end behaviors, either both pointing down or both pointing up. Always for an even degree. Remember, odd is when you have the opposite. Okay, so when you graph those, you are going to always get a value that is either a maximum value or the minimum, the least value that of your graph can reach. So that is why they have a absolute max or an absolute min, and all of them will. All polynomial functions with an even degree will have an absolute max or min. Okay, so don't get confused on that. Okay, back to our worksheet. We're going to do the second half of it. So we're now going to look at, we've just looked at even degree. If you notice that all of those ones on the front were even degree. The other second part of this worksheet, they're all odd degree. Okay, so looking at that first example, we have a degree of 3. It is an odd degree. Our leading coefficient is positive 1. Okay, so because remember, so this is the kind of the harder one. So because it's positive, it's going to end on the right, pointing up. Okay, then your end behavior, so as x approaches negative infinity, y is approaching negative infinity. As x approaches positive infinity, y is approaching positive infinity. Okay, then your number of turning points is 1, 2. And your number of zeros is 1, 2, 3. So again, same rule is going to follow. So number of turning points is 1 less than your maximum, 1 less than 1 minus your degree. And then number of zeros is maximum what your degree is. So 3 in this case, we have 3. Okay, so moving on to that next one, we have a graph that looks like this. It is a degree 5, which is odd. Our leading coefficient is positive 2. So again, remember, a positive coefficient is going to end up to the right, opposite end behavior. So it's going to have to start down to the left. Okay, as x approaches negative infinity, y is approaching negative. As x is approaching positive infinity, y is approaching positive. Okay. You have number of turning points here, 1, 2, 3, 4. Okay, and then your number of zeros is 1, 2, 3, 4, 5. Okay, so again, 1 minus your degree is your number of turning points, and maximum your number of zeros is your degree. Next example here, we have a degree 5. And that is okay that it only has 2 turning points. Remember that the maximum number of turning points is 1 minus, but it can have anything under that. So you do have 2 turning points. I'm going a little out of order, sorry here. You have 3 zeros. Okay, you're a degree 5. It is odd. Our leading coefficient is positive 5. As x approaches negative infinity, y approaches negative infinity. As x approaches positive, y is approaching positive. Okay, so just an example there where like the number, the degree 5 doesn't necessarily match up with your number of doing 1 minus your number of turning points, but it can be anything under that. Excuse me. So here's another graph. You have negative 2x to the exponent 3 plus 4x to the exponent 2 minus 3x minus 1. You have a degree of 3, which is odd. Your leading coefficient this time is -2. So remember that means that negative means that we're going to go finish down to the right. Okay, and then opposite end behavior, so we have to start up to the left. Okay, our end behaviors, as x approaches negative infinity, y is approaching positive infinity. As x approaches positive infinity, y is approaching negative infinity. Number of turning points, we have 1, 2 turning points, and our number of zeros is just 1. Okay. So for that, again, for that on your worksheet, you should be pretty comfortable with looking at the graph and coming up with those 6 different things that you see here. Well, yeah, 6. So your degree or even or odd degree leading coefficient, what your 2 end behaviors look like, your number of turning points, and your number of zeros. Okay, so again, going off of that chart into writing back in your notes, we're going to look at a couple of examples like we just did for even degree. We're going to look at them for odd degree. Okay, so determine the end behaviors of each function, the possible number of turning points, possible number of zeros, use the characteristics to sketch possible graphs of the function. So we have an odd degree here. So we know that since it's odd, it's going to be opposite end behaviors. Okay, and we know that it is a negative coefficient. So when you have a negative leading coefficient, we're going to finish down to the right. So if you were to kind of sketch that, you know, you're going to finish down to the right, which means that you have to start up to the left. And then the maximum number of turning points you have in between is 1 minus this 5, so 4. And the maximum number of zeros you have is 5. Okay, again, that is just from practice. So exactly what I just said, the degree is odd, so the function has opposite end behaviors. The leading coefficient is negative, so the graph must extend from the 2nd quadrant to the 4th quadrant. Okay. Your end behaviors, as x approaches negative infinity, y is going to approach positive. As x approaches positive, y approaches negative. Okay. So using the end behaviors of the function, sketch the possible graphs of 5th degree polynomial. To pass through the 2nd quadrant and extend to the 4th, it must have an even number of turning points. So 4 or 2. Okay. So here, or 0 turning points. Okay, so examples here, this technically has 0 turning points because your y values keep decreasing. They never go back up and start increasing to then go down and decrease again. Okay, so you have 0 turning points, you have 2 turning points, or you have 1, 2, 3, 4, 1, 2, 3, 4, or 1, 2, 3, 4. So examples here. Remember that for our zeros, we can have 0, 1, 2, 3, or 5 zeros. So that's why they have given you all these examples. 1 0. This is 3 zeros. This is no zeros. Okay. This is 1, 2, 3, 4, 5 zeros. And then this is 1, 2, 3, 4 zeros. So lots of different examples there. The key here, though, is that it's going to pass through that 2nd quadrant, extend into the 4th quadrant, because we knew that we had to have our opposite end behavior. So it has to look something like that with either 0, 2, or 4 turning points and a maximum of 5 zeros, anything down to 0. Okay. Sorry, it would never have 0 because it has to pass through the x-axis at least once. Okay. Another example, looking at your summary at the end of your worksheet, what you noticed about end behaviors and what you noticed about the leading coefficient. Okay, so for the degree, the odd has opposite end behaviors, the even has the same end behaviors, so you know that. If it's positive, your leading coefficient is positive, and if it's negative, you know that your end behaviors are negative infinity, positive infinity, and positive infinity. They're opposite. Okay, then same, so go negative. these are negative infinity, positive infinity, negative infinity. And then even are either as it approaches positive or negative infinity, it's going to approach positive infinity. Approaches positive or negative infinity, it's going to approach negative infinity again. So you get used to that as you see the graphs and you go through that. So that's a little summary for you. Okay. Those are examples of your graphs for what they would look like for an odd positive, an odd negative, an odd even, an even positive, and an even negative. Okay. Then we're going to look at a couple more examples. And then I'm going to get you to do some practice. Okay, so what could the graph of a polynomial function that has range, y is an element of the real number system such that y has to be less than or equal to 10 and 3 turning points look like? What can you conclude about its equation? Okay, so for that, you know that if it has a range, that has to be y is less than or equal to 10. Well, if you're graphing that, here's 10, you know that your graph has to be under here, which means that it has to, or regardless if it looks like this, here's 10, it could have like however many turning points, right? But all of these numbers have to remain under 10. So you know that the equation has to be an even degree equation and it has to have a negative coefficient out front, okay? Because you can never go higher than that 10. So to get us to have our negative end behavior here, we have to have a negative leading coefficient. And we have to have a even degree for both of our end behaviors to be the same, okay? So some of the possible graphs could be, remember, if we're looking at an even degree, okay, so we could have like two turning or zeros with 1, 2, 3 turning points. We could have 4 zeros with 3 turning points. We could have 3 turning points with 1, 2, 3 zeros. Okay, so those are just possible graphs. Are there lots more examples? Yes. Okay, so don't worry. And just remember that the function has at least 2 zeros. Okay. For this again, what can you conclude about its equation? You know that the end behaviors as x approaches negative infinity, so here your y is going to approach at negative infinity as x approaches positive infinity, x is going to approach negative infinity. So looking at those end behaviors, you can come up with, just given this information, you can come up with what end behaviors have to be. Okay, it has to be an even degree, which I already said. And the degree of the function is at least 4. And that is based, because it says it has 3 turning points, right? So if it has 3 turning points, it can't be only 2, a degree 2, because it wouldn't turn enough. A degree 2 would only have 1 turning point, okay? So that is what you can conclude there about that function, okay, and that graph. So what I'm going to get you to do is sketch a polynomial of degree 4 with a negative leading coefficient, and sketch a polynomial of degree 3 with a positive leading coefficient. So again, you are sketching. Okay, is there only one right answer? No, because you know that a degree 4 can have up to 3 turning points, and it has a negative leading coefficient, so it can have 0 to 4 zeros. Okay, so there's lots of different graphs that you can draw there. Again, degree 3 can have up to 2 turning points, and with a positive leading coefficient, remember that that is going to have to end in that one quadrant, in that first quadrant, and it's going to have to end in your third quadrant, okay? So you know that that is an example. So you're going to take a second, pause the video, and you're going to try to sketch an example of these. Okay, so now that you're done sketching, I'll show you an example of something that could have been drawn. So you know that it's degree 4 negative leading coefficient, so you know your end behaviors are going to be going down. You know that you have 3 turning points, so 1, 2, and 3 turning points, and it can have from 0 to 4 zeros. This example has 2, okay? You could have drawn something that had this come down lower and then came up, so then you'd have 4. It's up to you, okay? And then sketch a polynomial to degree 3 with a positive leading coefficient. So you know that it does have to end in your first quadrant and start in your third, okay? Again, you can have up to 2 turning points. This example has 2 turning points, and you can have up to 3 zeros. This example only has 1. Okay, so but you could have drawn one with two zeros or 3 zeros. Again, on this next slide, before you're going to start homework, you are sketching a polynomial with degree 2 with a positive leading coefficient. That should be pretty easy for you. Degree 2 is a quadratic. Positive leading coefficient means it has to point up. Okay, and then sketch a polynomial with degree 5 with a negative leading coefficient. Okay, so pause the video, attempt to draw those out, and then I'll put up some examples. Okay, now that you've paused the video, you're going to sketch a polynomial with degree 2, positive leading coefficient. Okay, has to be a parabola pointing up, because you can only have maximum 1 turning point. Okay, this example, we could have had 2, like we could have drawn something down here, right? And then you would have had 2, or you could have drawn something like this, and you would have had 1, 0. So you could have 0, 2, or 1 zeros, okay? And then sketching a polynomial with degree 5, so a little bit more complicated. We can have maximum 4 turning points, and we can have maximum 5 zeros. So this example has 1, 2, 3, 4 turning points, okay? You know that we have a negative leading coefficient, so we have to end negative. So we opposite, we have to start positive. And then you are able to have a maximum of 5 zeros. This example has 1, 2 zeros, okay? So again, those are examples of sketches with that agree with that criteria. There are lots and lots of examples. So on a test, there's not going to be, or whatnot, not necessarily in your homework either, there may not be an exact answer for some of them. You just have to make sure that it agrees with that criteria given, like whatever the degree and the coefficient is. Okay, so there is no homework posted at the end of this lesson. Okay, so because there's no homework posted, it was in part 1 of this lesson. So you're going to go back to part 1 of this lesson. And the homework was listed there, or access it from your outline. So the outline is, it's going to be on page 86, number 1 to 6, 9, 13, 14, 15, and 17. Okay, so now that you've filled out this worksheet, have a little bit better of idea how to actually sketch polynomial functions given equations, and read a graph and tell me information about it. You kind of know how to go both ways. You should be set for this homework. Okay, so good luck. Let me know if you have questions. There probably is going to be some because this stuff is brand new. So make sure you're emailing me and asking me questions. Okay, good luck.